Torsion fields, instant messages to the stars. I mean, it sounds like something straight out of science fiction, doesn't it? But what if it wasn't? What if there was a way to communicate across the insane vastness of space instantly? Okay, let's dive into the source material behind this idea and see what it's all about.
So, the first thing you need to wrap your head around is this number. 4.2 years. That's how long it takes for a simple radio signal, traveling at the absolute speed limit of the universe, light speed, to get to our nearest stellar neighbor, Proxima Centauri. Over 4 years for a one-way message. That's the wall we hit with any kind of communication outside our own little solar system.
So you gotta ask, right? Is there a faster way? Could we ever, have a real-time chat with someone or something on a planet orbiting another star? Well, the material we're looking at today explores a pretty radical theory that says, maybe, yeah. The authors behind this theory propose something they call the instantaneous field. They basically describe it as a potential fifth force of nature, something totally new, beyond the physics we know, that could just sidestep that cosmic speed limit altogether. And the heart of this whole idea is something called the torsion field. The source defines it as a field that's generated by spin or rotation, and it acts as a carrier. And here's the wild part, not just for data, but for information, thoughts, and even emotions. The properties they claim these fields have are, well, they're pretty extraordinary. They say they're generated by any spinning object, a planet, a star, even a spinning top. They propose these fields spread out across the entire universe instantly, and they create a kind of subtle aura. But the most important part of the theory, the part that makes it all work, is that last one. They claim these fields can actually be detected.
Now, this isn't some brand new idea they just cooked up. The source material actually traces it all back to some much earlier and, frankly, very controversial work. We're talking about something called Kozier's cosmic anomaly, an experiment from way back in the 1960s that claimed it had detected a signal that broke the speed of light.
You see, this theory didn't just pop out of nowhere. The source lays out this whole history, going back almost a century. It starts in 1913 with a mathematician named Eli Cardin and his abstract concept of spinors. Then nothing, really, until the 60s, when Russian astrophysicist Nikolai Kozyrev runs with it and does his crazy experiments. After that, in the 80s, A.E. Akimov starts thinking about it for communication, and it all leads up to G.I. Shipov's theory of physical vacuum in 1998.
So, how in the world did Kozyrev's experiment supposedly work? Well, it was actually pretty clever. First, he'd look at a star's visible position, where we see it in the sky. But of course, that's its position in the past because of the time it takes light to get here. Second, he'd do the math to figure out where that star really is, right now. Then, he'd point a special torsion field detector at that real spot. And the result? He claimed the detector picked up a signal right away, instantly.
The implication of that was just staggering. The source authors sum it up like this. Information via TF is appearing everywhere in universe at once. And you've got to pay attention to the wording there. It's appearing, not traveling. It suggests information doesn't have to go from point A to point B. It can just be everywhere at the same time.
Okay, so that's the theory. But what about the actual tech? This brings us to what I can only describe as garage-built ghost tech. These really strange devices they've designed to try and harness these fields. So this right here is a magnetic rotator torsion field generator. According to the source, it's really just two coils of wire wound at right angles on a ferrite disc, which is kind of like a magnetic ceramic. I mean, look at it. It's so striking how simple it is. It looks like something you could build in a workshop, and yet this is what's proposed as a device for instantaneous communication across the stars.
And how do you even pick up these fields? Well, the source shows a couple of options. On the left, you've got a pretty standard-looking magnetic coil sensor. But on the right, that's something else entirely. It's a detector that uses a levitating plate of a special carbon material that just floats above magnets. The idea is that a passing torsion field would give this floating plate a tiny, tiny nudge, a little wiggle, that you could then measure. Okay, but this is where it gets truly, truly wild. You can have a transmitter and a receiver, sure, but how do you address a message? How do you dial a cosmic phone number? The author's answer is, you use a photograph as an antenna. So this is the absolute core of it. The authors propose that two copies of the same object, say two photos printed from the exact same digital file, are fundamentally connected. They say they're in relationship and can basically feel each other instantly, no matter how much distance is between them. This supposed link is the foundation for their entire communication system.
So here's how the source material claims this whole thing fits together. You've got your transmitter, and it impresses a signal onto its photo. Then, miles or light years away, the receiver has the identical photo sitting on a detector. The theory is, when the transmitter's photo gets zapped with a signal, the receiver's photo reacts at the exact same moment, and the detector picks up that reaction. The photo is the key.
Now, I know this all sounds very theoretical, but the authors claim they actually put it to the test. So let's look at the 8,000-kilometer test call, an experiment they say they ran between Australia and Russia.
Okay, so here was the setup for their 2011 experiment. You had the transmitter in Perth, Australia. The receiver was all the way in Tomsk, Russia. We're talking about 8,000 kilometers apart. And the antenna? Get this. They took a photo of the transmitter, emailed it to the team in Russia, who then printed it out and placed it on their detector. That's it. Then, back in Australia, they just flipped the switch on the transmitter.
So what happened? Well, they say a signal was detected, but, and this is a huge but, it wasn't instant. There was a pretty big time delay, sometimes up to 30 minutes, or even more.
Now, this is where their argument gets really interesting, because you're probably thinking, well, then it wasn't instant. But they claim that delay has nothing to do with the distance. Let's compare. With radio, the delay is caused by the distance. Light speed takes time. In their proposed system, they argue the signal itself is instantaneous, and that 30-minute delay is just caused by the local equipment, the time it takes the parts to warm up and react. So in their view, a message to another galaxy would have the exact same 30-minute delay. The distance just doesn't matter.
And this brings us to one last, really mind-bending thought. Let's be totally clear. These are extraordinary claims that are way, way outside of mainstream physics. But just for a second, let's play what if. If a message could appear anywhere in the universe instantly, what would that really mean for our most basic understanding of space, time, and maybe even consciousness itself?